Good morning, students. I hope you all are doing fine. So we were discussing about the matters. So today we will be discussing about the particles of matter that attract each other, because in the last class we were discussing about the Brownian motion of the particles, which you guys did not mention in your practical notebook. Okay. So today we will be discussing about particles of matter that attract each other. So in your activity 1.8, they are asking you to put your finger in water and try to slide it, try to move it. What happens if you are cutting water? They are asking you to cut the water. What you are experiencing? You are experiencing that water comes back, isn't it? Water is coming back. So what exactly happening? It is happening that the particles of the water attracts each other, so they are coming back, isn't it? So like this, in this universe, all the matters, every matters attract each other. I am attracting you, you are attracting me, the board is attracting me, I am attracting board. Okay, but the net force between us is 0. That's why we are not moving. Okay, the net force between us is 0. That's why we are not moving. Earth, our mother Earth is also pulling us downward. That's the force which we are experiencing due to Earth is known as gravity, isn't it? So every particles in this universe are attracting each other. Okay, every particles are attracting each other. Some particles are attracting one another with low intensity, okay, with the least force, but some are attracting each other with the strongest force. Okay, so we will be discussing about the states of matter. On that basis, I would like to ask you to go through activity 1.7, 1.8 and 1.6 thoroughly to understand this concept. Okay, and let's switch to other topic. Yeah, I would also like to ask you to kindly go through these questions. You have a very good questions over here. The questions are: which of the following matter? Chair, air, love, smell, hate, almonds, thought, cold, lemon, water, smell of perfume. They are asking you to find out the matter. So what is matter in this in these options? You will have to find it out and give reason for the following observations. The observations are written over here. A diver is able to cut through water into a swimming pool. So the same question which you will have to go through. And what are the characteristics of the particles of matter? So characteristic of the particles of the matter, you will have to note it down, which I have mentioned in the first video lecture. Okay, so let's switch to another page, which is states of matter. Yeah, let's see states of matter. Okay, let's see states of matter. So what I was saying you, that every particles attract each other, okay, but some particles attract each other with least force, some with moderate force, but some with maximum force. Okay, they attract each other with maximum force, so they won't separate. Okay, the particles you try to separate, they won't separate easily. Okay, because they are experiencing maximum force between them, isn't it? So these kind of particles they make up, they are known as solid. So on this basis, the matter is divided into 5 classes, but in 9th class we will study only 3 types. Okay, we will study only 3 types, that is solid, liquid and gases. Okay, so first today we will discussing about solid states of matter. That is, our first is solid. Let's try to understand solid. Suppose this is a solid, any material, suppose solid bricks. Okay, solid brick. So if you try to break this brick, what you will have to do? You will have to apply force over here. Okay, you will have to apply force, which is generally very much. If I ask you to break, suppose this chalk, and this brick, you will say this can be, this chalk can be easily broken, but not bricks. Okay, so what it is happening, the particles, see, the particles, the matters, which I am trying to show here, spherically. Suppose the particles, the matters are in spherical shape. So they are compactly packed, okay, and they attract each other with maximum force, okay, they attract each other with maximum intensity, maximum force, okay. The force of attraction here is maximum. The particles, they don't want to be separated, okay. If you try to separate these particles, they don't want to be separated, okay. They just want to live together, they just want to be together. You cannot separate it easily, okay. So you can say that here the intermolecular force of attraction is very high. In solids, these are molecules. So suppose this molecule and this molecule, they both molecule they are attracting each other, and I am saying that they are experiencing maximum force, okay. I am saying they are experiencing maximum force. So what is happening, you can say that these molecules are having maximum intermolecular force, isn't it? And which type of force? Repulsion or attraction? It is attraction, okay, because they want to live together. If they just don't want to live together, they must be experiencing repulsive force, but they are living together. That's why we can say that they are experiencing attraction, force of attraction. So in between these particles or these particles or these particles or these particles, all the particles in solid, they are experiencing maximum intermolecular force of attraction. Intermolecular because we are talking about different molecules. If we were talking about same molecules, then we could have easily used intramolecular, okay. Intra word is used for the same thing, within thing. Suppose if you are transferring money to the same bank, that means you are doing intra-bank transaction, and if you are sending into another bank, then you are doing interbank transfer, okay. So that's what I'm trying to say, that these both molecules are different. So the force is experienced by these molecules are, first of all, solids have maximum intermolecular force of attraction. So in solid, they are having maximum intermolecular force of attraction, okay. Maximum intermolecular force of attraction, okay. So if these molecules are experiencing maximum intermolecular force of attraction, so what do you think? The gaps or the space between these molecules must be least, isn't it? The space between these molecules must be least, okay. So the space in the solid, the molecules in the solid, they are experiencing least space, okay. So I can say that intermolecular space, these molecules and these molecules, if they are experiencing maximum intermolecular force of attraction, that means they are together, that means the space between them is negligible or almost zero, isn't it? So I can say that intermolecular space between these molecules are almost nil or almost zero, okay. So the intermolecular space in solid is very less, okay, in comparison to liquid and gas. So our next point is that because they are inversely proportional, if the intermolecular force of attraction is maximum, the intermolecular space will be minimum, isn't it? So that's what we can write here. Minimum intermolecular space. Minimum intermolecular space. Minimum intermolecular space, okay. That's quite good. So what we have learned is two things, that molecules in the solids are attracting each other with maximum intermolecular force. Okay, cool. That's why they are experiencing minimum intermolecular space. Okay, that means they are compactly packed because they do not possess maximum or large gaps between them. Okay, so they are incompressible. Okay, they cannot be compressed. If I ask you to compress a iron, or if I ask you to compress this chalk holder, you cannot compress it. You will say this is solid. Okay, you cannot compress it because they are intermolecular. Their molecules are already touching or overlapping each other. So how you can compress these particles? They are already touching, na? They are already touching each other. So how you can compress? How you can make them come more closer? They are already close. Okay. So the solids are incompressible just because of these 2 points. Okay. So our third point is solids are incompressible. Solids are incompressible. Solids are okay. Solids are almost incompressible. Compressible. Okay, that's cool. They have rigid shape, they have fixed shape, they have fixed volume. Okay, they have fixed size. You can see they are fixed size, fixed volume. If that's why, not that's why, because their particles are experiencing maximum intermolecular force of attraction. That's why the point is they have, fourth point, they have fixed shape, size and volume. If I talk about the density of the solid, what will be the density of the solid in comparison to gas and liquid? What we are comparing solid, if I'm saying maximum, minimum, that means I'm comparing the solid with other states of matter, that is liquid and gas. Okay.